Welcome students to the series of lecture on hypothesis testing, and in this series of lecture of hypothesis testing, this is our fifth lecture where we'll cover step 4, calculate the test critical value or T critical value or test critical value. So we'll keep the discussion for step 4 only where we'll calculate the critical value. But first, let's understand the journey so far. In hypothesis testing, we said there are 5 steps. Step 1, define the hypothesis. You define the null hypothesis. You define alternate hypothesis. Perfect. In step 2, you define your distribution. That distribution could be normal distribution, could be t distribution, could be chi-square distribution, could be f distribution. It could be any distribution depending upon the problem statement we discussed in session 3. Step 3 is to calculate test statistics. Now, step 3 is what? To calculate the test statistics, but it directly comes from the formula. That was our last session. We covered this. We said, so if you're using normal distribution, use Z formula. If you're using T distribution, use this formula. If you're using chi-square distribution, use this formula. If you're using F distribution, use this formula. So step 3 comes directly from the formula. What? Test statistics. The step 3. Now today we'll discuss step 4. Step 4 comes from a table. What? A table. If you're using normal distribution, you will use a Z table. If you're using T distribution, use T table. If you're using chi-square distribution that you decided in step 2, you decide distribution in step 2. Whichever distribution you decided, you choose that table. Chi-square distribution, chi-square table. F distribution, F table. So the rule of thumb is to find the critical value, look into the tables. Look into the tables, depending upon what distribution you have chosen in step 2. Now, the table is there. It is given in your curriculum and it would be provided during your examination. But what are the other information needed to find your critical value? You cannot find critical value just looking into the table without any information given. The first thing that you need to know is type of test. What type of test? Whether it is a left tail test, whether it is a right tail test, or it is a both tail test or two tail test. This information comes from step 1. Comes from step 1. Because in step 1, what you do, you define your alternate hypothesis. You define your alternate hypothesis. That is your belief is your alternate hypothesis. If in the alternate hypothesis, there is a greater than sign, if you're writing alternate hypothesis greater than sign, it is a right tail test. If there is less than sign, then it is a left tail test. If it is not equal to, then it is two tail test. Second, you always need significance level. You always need significance level. If the significance level is not given, you cannot solve any hypothesis testing question. If the significance level is not given, you cannot solve any hypothesis question that need to be provided in the examination. Significance level simply means area in the tail. What it means? Area in the tail. If this is the distribution, then what is the area in the tail? If there is a right skewed distribution, then this is the area in the tail. So what is the area under the tail? If the area under the tail or the significance level given as 5%, you have to cover 5% area in the tail. Which tail? It depends upon whether it is a right tail test, left tail test, or two tail test. That's it. Perfect. So you need significance level. The third information which is required is the degree of freedom. First was type of test, whether it was right tail, left tail, two tail. The second is the significance level, the area in the tail. Significance level is area in the tail, and then degree of freedom. We know that when we discussed in our statistics series of lecture, when we discussed T distribution in depth, when we discussed chi-square distribution in depth and F distribution in depth, we said we need degree of freedom to look into T distribution table. So you need degree of freedom. What is the degree of freedom in T distribution? It is n minus 1. In chi-square distribution, it is a number of standard normal variables, but it will have 1 degree of freedom. Do you remember F distribution has 2 degree of freedom? So until and unless you have degree of freedom information provided, you cannot solve. You cannot solve for the critical value for T distribution, chi-square distribution, and F distribution. And in F distribution, you need 2 degree of freedom. So remember that. Okay. Now, Assume that in step 2, you have chosen normal distribution. You have chosen normal distribution. Then how you will find the critical value? So let's start with a right tail test. Suppose in step 1, you define that it is going to be a right tail test. Then what you look for? Step 1 has been defined for the critical value. The step 1 has been defined that it is a right tail test. Okay. What is the second thing? Significance level. Say the significance level for our example is 5%. It is 5%. What is significance level? Significance level is an area in the tail. What is significance level? Significance level is area in the tail. Since it is a right tail test, what you will do, you will cover 5% area in the tail. How much area in the tail? 5% area in the tail if it is a right tail test, because you have to cover in the right tail. Then if you keep on covering 5% area in the right tail, you get this point. This point is critical value. This point is critical value. In normal distribution, we said this point is z-score or whatever, but this point is critical value. And this comes from a table. So now we move to Z table. Which table? Z table. So let's move to Z table. This is the Z table information that we have. So, okay. So you have your Z table. Since it is a right tail test, you covered 5% of area in the right tail. You achieved or you reached this point. And when you look into the Z table, important thing that you have to understand that this section gives you the probability. This section gives you what? Z score. Right? We discussed in one of the session of normal distribution. This section gives you the probability and this gives you Z value. Now, because you cover 5% area in the right tail and this is the image, so this area becomes 95%. So you look for 95% or 0.95. So let's look for 0.95. 0.95. 0.95 is between these two values, which is 4 and 5, and this is 1.6. So I can say that the z score for this value is 1.645. Z score for this value is 1.645. If you don't know z score, please watch normal distribution sessions. So z value is 1.645 and this is your critical value. This is your critical value. If this would have been a left tail test, then again the z score would be 1.645 but negative 1.645 because it is a mirror image. Okay. What if the significance level is given as 5%? But if it is a two tail test, if it is a two tail test, then what you need to do? You need to first divide this significance level, the area in the tail, by 2, because you will cover 2.5% in the left and 2.5% in the right. So now if you look into Z table, you will look for which area? You will look for this area. What is this area? What is this area? This area would be 97.5% because this area is 2.5%. So this has to be what? 97.5%. So let's look for 97.5%. 97.5%. That is 1.96. 1.96. So that is your critical value. 1.96. If this is 1.96, this has to be what? Mirror image. So it is 1.96. And that is the critical value for two tail test. That's it. So what is the important thing? The important observation, if you had looked carefully, in normal distribution, you do not need a degree of freedom. You only need two information. You only need two information. What you need? You only need type of test and you need significance level. You don't need degree of freedom. But in T distribution, in chi-square distribution and F distribution, you need degree of freedom. Otherwise, you cannot find out your test critical. Okay. So for T distribution, chi-square distribution and F distribution, we have to look for degree of freedom. So let's understand it for T distribution. And if you understood it for T distribution, then you would be able to find the critical value for chi-square distribution and F distribution. Okay. So to find the critical value in T distribution, you need three steps: type of test, significance level, and degree of freedom. So type of test could be right tail, left tail, and two tail. The significance level is the information that would be given in the test. And in our example, it is 5%. It could be 10%, it could be 7.5%. It depends upon the problem statement. But it would be given in the examination. Now we need a degree of freedom. The degree of freedom is n minus 1 for t distribution. And suppose the sample size is 21. So the degree of freedom is what? 20. So the degree of freedom is 20. Perfect. So in our example, we have degree of freedom as 20. Let's look for right tail test. So what we need? We need a t table. So do we have t table? Yes, we have t table. What we have to look for? We have to look for 5% area in the tail. But which tail? One tail or two tail? One tail, because we are looking for right tail, not both tail. Right tail test. So 5% area. So 5% area. Perfect. Which degree of freedom? 20 is the degree of freedom. So what is the value? 1.725. That is your critical value. 1.725 is your critical value. So this point is 1.725. If this would have been a left tail test with a 5% significance level, because even t distribution is a symmetric distribution, because t distribution is a symmetric distribution, it has a skewness of 0. Then if this would have been a left tail test and you cover 5% of the area, then this point would have been negative 1.725. Because when you cover 5% of the area, then this value would be 1.725 standard deviation away from the mean, because that is the definition of t score or z score. Perfect. But if this would have been a two tail test, then what you have to do? You have to cover 2.5% area, 2.5% area equally in both the tail, right tail and left tail. So because this is a two tail test, we have to look for 2.5% area in one of the tail, or for two tail, I will look for 5% area, because both the information is given in the t distribution. So see, if you look for two tail test, if you look for two tail test, then you look for 5%. But if you look for area in one tail, you will look for 2.5%. Both of them is the same column and the degree of freedom is 20. So if you look into this column and this row where the degree of freedom is 20, this is the intersection and this point is 2.086. This point is 2.086. That is your critical value. So this is your critical value 2.086. If this is positive, then this has to be negative 2.086 that we discussed in t table discussion or t distribution discussion. Okay, so we have understood that test statistics comes from the formula. Critical value comes from the table. But to find critical value, you need type of test, whether it is a right tail test, left tail test, or two tail test. Important information. You also need to know whether you have the significance level provided in the question or not. If not, you cannot solve the question. The third, you need degree of freedom for t distribution, chi-square distribution, and f distribution. Now, one caveat is that chi-square distribution and f distribution most of the time are right tail test, and f distribution is most of the time, 100% of the time, is a right tail test. Okay. Once you have this test statistics and critical value, if you have these two number, what do you have to do? You have to just compare these two number and you can find and you can finally decide whether you have to reject the null hypothesis, whether you fail to reject the null hypothesis, as in step 5. And that you do with the help of test statistics, comparing test statistics and comparing the critical value. And this is where the hypothesis testing gets completed. So in the next lecture, we'll finally close the loop and understand how the decisions are made in hypothesis testing. What is rejection area? What is the acceptance area in a hypothesis testing? With that, I'll pause here. Thank you. Have a nice day.